7.5 looks at multiplying rational expressions. So when we multiply rational expressions, what we do is multiply the numerator, multiply the denominator, and then simplify. Another way we can do this is by canceling common terms right from the start, as long as there's one in the numerator and one in the denominator. So if I look at this, I could multiply across. I could do 59 times 80n all over 99 times 33n. Right away, I'm going to see I can divide the top and bottom by n, and those will go. Okay, when I multiply across the top, I see that 50 times 80 gives me 4,720, and I see that 99 times 33 gives me 3,267. I can try to simplify each of these, or the top and bottom, and find factors they have in common, but they don't have any, so this actually ends up being my final answer. Let's look at a different example on here. Let's look at number 7. Number 7 I could multiply across, but if I look, I notice that I'm going to have an r plus 2 on the top and an r plus 2 on the bottom. So one in the numerator, one in the denominator. Remember that really it's 1 over 1. So I'll just continue to multiply the pieces I have left behind. So on the top I have 6 times 4r, and on the bottom I have 20 times 6. So on the bottom I have 20 times 6. I could cancel here, but I don't have to, because I'm going to end up with 24r over 120, and I could cancel. You'll notice it would just be easier from this point to divide the top and bottom by 6, because this is really a 1, and get that 4r over 20, divide the top and bottom by 4, and my final answer here is actually r over 5. Okay, so let's recap. I multiply across the top, I multiply across the bottom, or I can cancel and divide the pieces they have in common right from the start and look for factors that remain, and all I'm really left with is an r and a 5, which was my final answer. Just make sure you're keeping track of what's in the numerator and what's in the denominator. Let's look at number 8. When it's already in factored form like this, it ends up being really nice for us, and we can just cancel anything that numerator and denominator. They don't have to be in the same fraction in order to cancel, because remember, if we multiply across, it would all be one giant fraction. So I would really have 7n squared times n plus 4 times n minus 3 all over top of n minus 3 times n plus 4 times n plus 8 times n plus 6. So it really doesn't matter if it shows up in the left fraction or the right fraction. What matters is that it's one in the numerator and one in the denominator. So like you saw, we canceled the n plus 4s. I can cancel the n minus 3. And what I'm left with is 7n squared on the top, and then an 8n, or I'm sorry, n plus 8, and an n plus 6 on the bottom. Doesn't matter if we leave it in a factored form or if we expand it, but I need to write here n cannot be equal to -8 or -6. Remember, that came from simplifying when we talk about what numbers would make our denominator undefined. So both of the examples we've seen so far, we don't have to worry about that because there was no variable. This is the first one where you need to worry about n cannot be equal to -8 or -6. And look back to 7.4 for that. It makes your denominator undefined. So let's look at one more example. I have x plus 7 all over 7x plus 35 times x squared minus 30x minus 40 all over x minus 8. Right off the bat, I don't see anything I can cancel, but I do realize I can factor this. So I'm looking for factors of 40 that are going to subtract to give me 3. They're 8 and 5, so I have x minus 8, x plus 5. And then down here, I take out a 7, and I have x plus 5. So when I multiply across, or I can cancel right away, I can cancel the x plus 5s, one in the numerator, one in the denominator, cancel the x minus 8s, one in the numerator, one in the denominator, and I'm left with an x plus 7 on the top, and I'm left with just a plain old 7 on the bottom. So for this one, I needed to factor first before I could multiply across. Look at one more example here. Number 17, it says 3b squared plus 18b all over b plus 6 times 1 over b plus 8. So again, I don't see anything right off the bat I can cancel, but I can factor this. So I can factor this into a 3b and be left with b plus 6. Factor by take out the GCF. And now I realize I have a b plus 6 in the top, a b plus 6 in the bottom I can go, and I'm left with 3b times 1 on the top, so just 3b, and on the bottom I'm just left with b plus 8, so in this case b cannot be equal to 8. A value of 8, or I'm sorry, excuse me, a negative 8 in the bottom would make my expression undefined. So we multiply the numerators together, multiply the denominators together, and then simplify. Very similar to multiplying fractions.